Hello students, welcome to my channel, and today we are going to discuss about a new chapter, that is atoms, molecules and chemical reactions. That is atoms, molecules and chemical reactions, right? And in previous chapter we learned about the atoms and molecules, right? So atoms are the individual particles of a matter and group of atoms are called as a molecule. So these things we discussed over there, and we discussed about like elements, compounds, mixtures, how to separate the mixtures. These things we discussed over there, right? So then what happened here means the scientists in the 18th century and in the 19th century, the scientists are very fascinated to know few things like in a burning reactions and in a combustion reactions, what is happening over there. So they are fascinating to know about that, because we know that a burning reaction means what? When oxygen react with any material, flame releases, that is heat energy releases, that we call as a burning reaction. Same concept we apply for the combustion also. Yes or no? That combustion means what? Reacting with oxygen and giving energy. Then what happened here? Suppose if you take a wood, you're burning the wood, suppose any wood material you're burning in the presence of oxygen generally, right? It releases carbon dioxide and some ash powder releases. Where does carbon dioxide is going? Does after the reaction the material is same or not when compared to the starting material? As already we know, before the reactions the materials are called as reactants, after the reaction they are called as products. These things we clear, right? Right. So what happened here, the reactants are similar to products or not? They want to know that. So this fascinated the scientists, and they try to discover what happens in the reactions, whether the reactants and products are same or not. Is there any change is there? Is there any change in the mass? Is there any change in the chemical composition? They try to discover all these things. So there we need to discuss about a person called Lavoisier, that is Anthony Lavoisier. Lavoisier, right? So he is the father of the modern chemistry, and he given one law for this, that we the different scientists, not only Lavoisier, next Joseph Proust and next some other scientists will comes over there. So they all are given certain laws. Lavoisier has given one law, and Joseph Proust has given one more law, and Dalton has given some concepts. So these laws we called as law of chemical combination. These laws combinedly we called as law of chemical combination, right? So whatever we are going to discuss further, they all include under laws of chemical combination. Okay, right? So what is there here? What Lavoisier said means, Lavoisier has given one law based on his observations. So what law he has given, what observation he made, let us say once. So that is Lavoisier gave law of conservation of mass. Law of conservation of mass. So in the name itself is there. What is meant by conservation? Protecting. That means no change in mass. That is conservation of mass. Mass is conserved. That means mass is protected. Where the mass is protected? That is before the reaction and after the reaction. That is a reaction. In a reaction, mass neither created nor destroyed. Listen carefully what Lavoisier said. That is given by Lavoisier, not by me, right? So what he said, that in a chemical reaction, the mass of the reactants is equals to the mass of the product. That is mass of reactants. Mass of reactants equals to mass of products. That is mass is conserved. That is no change in the mass. Before the reaction, after the reaction, mass will be same. That we called as mass neither created nor destroyed. Right? So that is given by Lavoisier. That we call as law of conservation of mass. And how he made the observations, what kind of observations he made, what lab activity he has done. So let us discuss here. So here we are taking one activity for the proof of this, right? So here I am taking lead nitrate, PbNO3 taken twice. So a pinch of lead nitrate I am taking and I am dissolving it in a test tube. Yeah. So a pinch of lead nitrate I am taking and added some water, so I dissolved it. And one more test tube I am taking. In that I am taking potassium iodide. Again same, a pinch of potassium iodide I am taking. So I have taken in a one more test tube. Right? Now take this lead nitrate. Into a conical flask. And add it into that. That is, take this lead nitrate, directly take the lead nitrate solution into the conical flask, right? So now take a weighing machine, electronic weighing machine you can use, or any weighing machine you can use. So take this, right? So measure the weight of this lead nitrate. What is there here? PbNO3 taken twice. Lead nitrate is there. Suppose you take it as, suppose 50 grams is there. Note down it as, that is W1 is equals to 50 grams. Note down it. Suppose, right? And next what happens? Again same conical flask we are taking. This same conical flask I am taking. In that I am inserting this second one. This is A test tube and this is B test tube, which contains lead potassium iodide. That one I am taking. This potassium iodide test tube I am taking and I am hanging it by a thread. With the help of a thread I am hanging it into the conical flask. In that I am hanging it. Okay. Now take the weight of this. Right? Now let us take it as W2. So suppose firstly it was 50. Now after adding the test tube, it may changes to suppose 70. Suppose, right? We are taking approximate values only. For generalization I am telling you this. Right. Now what happened here? Is there any kind of combination is there? No combination, no combining is there, no mixture is formed over there, right? So then what happens here? Same component of this, right? Conical flask is there along with the test tube. Now this one we need to tilt or we need to shake it to mix the contents by closing with the cork. We need to shake it. That is, two components should be mixed completely. So after mixing we will get a reaction. There you can identify that some reaction occurs, because firstly there was a plain solution and plain solution. After the reaction occurs, there is a precipitation will forms. That is yellow color precipitate will be forms, right? So now after the reaction, now here what happens here? Reaction occurs. Now again take the weight of the contents, right? So which contains test tube and along with the solution. Now what happens here? Reaction occurs. This is what? After the reaction, that is after the reaction. Now again take the weight. You will get as it is as a 70 grams only, like 70 grams. Here 70 grams, no? Now you will get the W3 as 70 grams also. Before the reaction occurs, before the reaction there was 70 grams. After the reaction also there was 70 grams. Mass has not changed. That is, no mass created, no mass destroyed. Right? So that reaction we called as what? That concept we called as law of conservation of mass. Here we are saying in terms of weight. We can say in terms of the mass also, like atomic mass also we can take. Like suppose if you have taken carbon if you have taken any wood material you are taking, suppose, and you are burning in the presence of oxygen, right? So what happens there? Carbon dioxide will be produced. Yes or no? Right. So here carbon mass is what? 12 units I am taking it as, and oxygen mass O2 is there, that is 32 units. And if you take the CO2, that will be like what? 44 units. See this, 12 units plus 32 units, that gives total 44 units. Simple, right? That is, mass neither created nor destroyed. And this exact observation is made by the Lavoisier. So that we are applying to all the reactions, right? Remember one thing, before you going to write this, you need to take a balanced equation. If you are writing like this, you need to take a balanced equation, right? So for this, let us write the reaction here. What happens here? PbNO3 taken twice plus potassium iodide. So we'll get it as a product like a PbI2. So here Pb is there, no? Here I is there, only one I is there. So for I2 is there, no? For balancing purpose, I'm writing here 2. So that PbI2 will get here plus 2K is there, right? And NO3 also 2 are there, right? So 2KNO3, and this PbNO3 is a PbI2 is a precipitation that we call as PPT, precipitation. A insoluble solid is forming in the reaction, that we call as precipitation, right? So this reaction occurs in the activity, right? And this reaction you need to write like a lab activity, like aim, apparatus, procedure, observation and results. So in that way we need to write the lab activity for this, right? So that is what law of conservation of mass. Repeat it again. How can we say that? The mass neither created nor destroyed in a chemical reaction, only the rearrangement will be there, right? So that we call as law of conservation mass is proposed by Lavoisier. Is that clear? Right.